Hello and welcome back to Mr. Powers Teaches Algebra 2. Algebra? This is more exponential functions. And I want to talk to you a little bit with sketching. A little sketching the graphs. So we've talked about these guys before. They're always positive above the x-axis, right? Ooh, unless we throw a negative out front. But anyway, let's not worry about that. Anyway, let's just do some sketches. We'll just plot out one little point, get the shape right, and move on. That's what we want to do in this one. So right here, and they're really quick, simple sketches. So 6 to the x. So we already know all of these guys, y equals b to the x, is going to look something like this. There we go. Or it's going to look something like this. Anyway, good enough. Okay, so they kind of look like this. They got this little shape here. And so with any base, I mean, that's what they look like, generally speaking, depending on the base. This guy is if the base is greater than 1. If b is greater than 1, this guy, b, is less than 1. Of course, b has to be positive, not 0, not equal to 1. So what does this guy look like? Well, he's going to look pretty much like our basic b is greater than 1 graph. And we got this special point here. Right there, I'm going to call it 0, 1. It's like, so there we go. We're going this way, and then it's going through here, and it's going up and up and up and up like that. There we go. And we got this point at 0, 1, and we got a y. We got a horizontal asymptote at y equals 0. That's pretty much it. We got that shape. Now, this guy looks very similar right here. That guy looks really similar, but now it's -9. Well, that's really easy. That's going to be the same as the one we just did, but it's just moved down 9. It's just moved down 9. So we're just going to say, you know what? Here's my asymptote. It's going to be at y equals -9 because we're moving all our points down 9. We're going to still have a special point right above there. And that's going to be 0, 8 because we moved this point down 9 also. So, sorry, 0, -8. -8. And it's going to have that same basic shape. It's going to look exactly the same. It's going to go. Give me that red. Here we go. It's going to be going like this. And then here it's just going to get closer and closer to that asymptote. That's generally what it's going to look like. Now this one is a little bit more complicated. This one's a little trickier. I think what I'll do is take a little screenshot of that. Okay. And he's going to be, again, a lot like this one we started with, 6 to the x. But what's the difference on that one? What's the difference on that one? The difference on that is, well, what is 6 to the x plus 1? That's not in our normal form. We like it b to the x. So can I get it to look a bit like b to the x? And I definitely can. 6 to the x is really just 6 times 6 to the x. That's the difference. So what am I doing now? I'm taking 6 to the x, which is this graph up here, the sketch, and I'm multiplying every single point by 6. So every point is getting multiplied by 6. So if I made a table of 6 to the x, which is what I got right above here, this one, if I made a table, all I'd have to do is take every y value of that table and multiply it by 6. So all the values are going to be a little bit higher than this. And I think what we'll do is we'll take a look at this in GeoGebra at the end of this. Okay, so that does change one of my points a good deal. Everything's going to be bigger. Still going to get close to 0, just take longer. This 0, 1 isn't going to be 0, 1 anymore. It's going to be 0, 6, multiplying it by 6. Multiplying that y value by 6. So that 0 is not going to be here. 0, 1 is going to be up here more like. 0, 6 is still going to have this shape where it's going up and up and up, but it's going to take a little longer to get big. Or no, they'll get bigger faster, sorry. It's going to take it longer to get close to 0 over here, but it will be getting close to 0 over here too. And so we still have that basic shape, but just the values are going to be a little bit larger generally, right? So that's what happens there. Let's go ahead and look at 2 more. I want to knock these out. Really, let's just look at 1 more. I really want to look at this here. Oh, you know what? We're going to take a look at this one really quick. So hold on 1 second. Okay, so here we can see the difference between 6 to the x and 6 to the x plus 1. We can see it very clearly. Here's our y-intercept 0, 1 for 6 to the x, and here's our intercept 0, 6 for 6 to the x plus 1. Exactly the way we had explained it. Shape is the same pretty much, as these values on the blue get higher faster. So if I zoomed in here, there's probably a gap. The blue is always going to be a little bit above the green because we're multiplying every value of the green, every y value, by 6 to get the blue. So that's what's happening, and we can see that also in our table of values. So let's go -2 to 10. Or, I don't know. Sure. No, let's go -4 to 4. That's probably plenty. -4 to 4. There's f of x, and let's get g of x in there. There, and now you'll be able to see 1, where we have 0, 1 for f of x, we have 0, 6 for g of x. Right? Multiply it by 6. 1, 6 for f of x, 1, 36. Multiplied it by 6. Multiply by 6. Multiply by 6. So you can see it in the table as well. And that's exactly what we'd expect to happen. All right. Last but not least, I want to look at this graph here. Can we sketch this graph? Well, you know what? We'll look at that one in the next video. So until next time, enjoy doing math.